can be decomposed. Okay, I'm going to start again. A vector, graphically, it looks like an arrow. The arrow indicates the direction that it has. It shows you where the arrow is going. Okay? In what direction is this vector going? Right or left?
Right.
Up or down?
Up.
Up.
Okay? So you can see that this vector is going up and to the right. Okay? So that's the first analysis that you need to see. Up and right. Secondly, what you do is you're gonna get the components. Imagine that I say that this vector has an angle of 30 degrees. Okay? That is this angle from here represents the direction at which it is going. And it is an angle that is going, it is a vector that is going at an angle of 30 degrees. Okay? I'm going to say that this vector is called A, and it represents a velocity of 100 kilometers per hour. Okay? That's what my vector is. So, this number, 100, represents the size of the vector. In other words, 100 represents how big the vector is. Okay? How big or small the vector is. The number 100, the vector itself, or what we know as the hypotenuse. It represents the size of the vector. Because vector, as a reminder, vector has two characteristics. Vectors have magnitude and vectors have direction. The magnitude is going to be denoted by the hypotenuse of the vector, and the direction is going to be denoted by the angle. Okay? So the magnitude and the hypotenuse are going to be the same thing. Now, you know this vector is going up and right, okay? That means that the components are going to come up. This is my component, vertical or horizontal component. Guys, this component that I just drew,
Vertical.
the vertical component. And the vertical is denoted by the subscript y. So my component of this vector is going to be known as a y. And this y represents, that is, the vertical component. The other component that I have is the horizontal component. You already told me that horizontally it is going to the right. So my horizontal component is there in green and is going to the right. So this is going to be my horizontal component. Therefore, you can call it AX. So of the vector is A and it is 100 kilometers per hour, but this vector can be decomposed into its components. AY and AX. This is horizontal and this is vertical. And remember the definition of subcatoa. Okay? I gave you the definitions for SOHCAHTOA. So, whenever you need to find the value of the opposite component, you're gonna be using SO. Why SO? Because of the definition of SO. SO is opposite over hypotenuse. Sine of the angle is going to be equal to opposite over hypotenuse. What is my opposite side to the angle in this triangle?
AY.
The angle is 30 degrees, and the side that is opposite, remember opposite is the same as in front. In front, I have AY. So, my opposite side is AY. So if I need to find AY, I need to use the trigonometric function SO. Okay? So for AY, that is opposite, sorry, AY is the vertical component, and this vertical component is opposite to the angle. Because it is opposite to the angle, we're going to use it to find the component. We're going to use SO or sine to find the component. So we say AY is equal to hypotenuse times sine of the angle. The hypotenuse is the magnitude of the vector, how large the vector is. So my hypotenuse is 100 kilometers per hour times the sine of the angle. This angle is 30 degrees. In your calculator, first in your calculator, you're going to press mode, the key, you're going to press the key mode, sorry, mode, and then where it says DEG, then you're going to press the number that it shows, that in this case is 1, okay? So in your calculator, mode 1, you have to press that, okay? After you have done that, you're going to apply the procedure 100 times, and you're going to press the key that says sin and then 30. How much did you get?
50.
50. Okay, very good. Wait, I'm trying to look for a calculator to project it. I know this calculator is a little bit different, but still, it's better than showing nothing. So, I repeat, mode, in your calculator you will press mode 1, and then to do the procedure it's just 100 times sine of 30 equals 50. So the component, the vertical component, AY, is 50, and you're still going to write the units, okay? The units are kilometers per hour. Now, this vector is going up or down? Where is the component going? Up or down?
Up.
Up.
Right.
Okay? It's going upright. Okay? So because it's going upright, it's gonna be a positive component. So your final answer to the vertical component is going to be positive 50 kilometers per hour. And that one matters a lot. The symbol matters. The symbol matters. Okay? Now, to get the horizontal component, you need to analyze where the horizontal is located. As you can see, your horizontal component is touching the angle. From there, okay? From there, it's touching the angle. Because it's touching the angle, we say that it is adjacent. And when we have an adjacent side, we're going to make use of the trigonometric function k. K, or cosine of the angle, is adjacent over hypotenuse. So, to find the horizontal component of this vector, we're going to be using, because it is touching the angle, we say that it is adjacent. Remember, because it's touching the angle, we say that it is adjacent. And if it is adjacent, we're going to be using cosine. So we say AX is equal to hypotenuse times cosine of the angle. Remember that the hypotenuse is the total vector, okay? The vector that we are using. Hypotenuse is 100 kilometers per hour times cosine of 30 degrees. So in your calculator, 100 times cosine of 30 degrees. How much did you get? Do you get the same as me?
86.60. 6.60.
Okay, 86.60. Very good. Remember that we still need to write the units, and these are kilometers per hour. Now, horizontally, where is the vector going? To the right or to the left?
It's going to be positive, Miss.
It's going to the right, which means that it's going to be a positive answer. And this, guys, is what we know as getting the components of a vector. Let's do one more example. Let's do one more example, okay? I have this vector over there, and it has an angle of 50 degrees, okay? The first thing that I need to do with this vector is I need to complete a triangle to see the components, okay? I'm going to complete a right triangle. So this right triangle is going to be like this. And like that. This is the first thing that you do with a right triangle, okay? And whenever you have a vector, this is the first thing that we do. Let's say that this vector is a vector B. I'm going to call this one B. And I will say that this one is 80 kilometers per hour, okay? That's my vector. Now, which color is the horizontal component? Red, green or blue?
Blue.
Okay, so my horizontal component is in blue in this case, and I'm gonna call it Bx. How is Bx according to the angle? Adjacent or opposite?
Adjacent.
Is adjacent, okay? So my vertical component is the one that is gonna be in front, and I'm gonna call it By. Now, vertically, where the vector is going? Is it going up or down?
It's going down. Right.
Down.
You have to see the arrow, okay? The arrow indicates that it's going down. So my vertical component
Going
needs
to be
to
negative.
show, that is going down. So my vertical component is going to be negative. Very good. And my horizontal component is going to the right or to the left? Horizontally, where is it going?
To
To
the
the
right.
right or to the left? It's going to the right. Okay? So, from this, you can tell, because it's going to the right, you know that this one is going to have a positive symbol. We already said that if it is adjacent, we're going to be using the trigonometric function cosine. And if it is opposite or in front of the angle, we're going to be using the trigonometric function sine. Okay? So when we calculate the components of this vector, we are going to say By is equal to hypotenuse, sine of the angle, and Bx is going to be hypotenuse, cosine of the angle. Y sine because it is opposite. Y cosine because it is adjacent. Okay, that's the first analysis that we do. Then all we do is we substitute the hypotenuse by the number. Okay, hypotenuse measures 80 kilometers per hour times sine of the angle. The angle is 50 degrees. How much is this?
$61.3.
61.28. Okay, let's work with decimal places. Okay, 61.28. You're gonna write the units as kilometers per hour. Okay, and then where is the vertical component going? Up or down?
Down.
It's coming down, and because it's coming down, it's gonna be a
Negative.
negative component. In x, It says it is hypotenuse cosine of the angle. So my hypotenuse is 80 kilometers per hour times cosine of the angle, that is 50 degrees. How much is this?
51.42.
51.42. Remember to write the units as kilometers per hour. Now, is it going to the right or to the left?
To our right.
Right.
It's going to the
be
right,
positive.
so it's going to be a positive answer. One way to see if the work that you did is okay is the components cannot be greater than the hypotenuse. Because remember, this is a right triangle where the longest side is the hypotenuse. So the components by and bx both need to be less than the hypotenuse. Okay, I need a volunteer to draw a vector, whatever vector you want. Just draw it, okay? Draw the arrow whatever way you want it. And thank you, volunteers. Thank you so much. Just for the record, I sometimes give you extra points for your participation, but ni modo, you didn't want it. Okay, this is a vector that I call vector C, and it is equal to 120 Newton. What is the first thing that you're going to do?
Make it a triangle.
And make the triangle, okay? I will turn this into a triangle, just like you said. Okay, where is this vector going? Up or down?
Up and
Up to our left.
Up and
To our left.
left, okay? Because it's going up, my vertical component is going to indicate the direction upward, and my horizontal component is going to indicate the direction left. Okay? Now, for the vertical component, I'm going to call it CY, okay? And for my horizontal component, I'm going to call it
CX.
CX. How is CY according to the angle? Opposite or adjacent?
Opposite.
This one is opposite. So what trigonometric function I have to use?
Sin because opposite over.
I
forgot.
So when it is opposite, you're gonna be using the trigonometric function that is called sine. Sine, okay? And therefore, because of that, because this is the one that is opposite, therefore CX is going to be adjacent. That's how I do it, okay? I identify the opposite side, then I know that the other one is going to be the adjacent. So from this, I can tell that CX is the adjacent, and if still I'm not sure, I see how is this side according to the angle. I notice that it's touching the angle in this part, so I say, it's touching the angle, so it is adjacent. Okay? And because it is adjacent in this side, I'm going to be using the trigonometric function cosine. So, the vertical component, is it going to be positive or negative?
Positive.
Positive because it's going up. The horizontal component is going to be positive or negative?
Negative.
Negative because it's going to the left. This is what you're going to expect when you calculate the components. So, CY is equal to hypotenuse sine of the angle, and CX is equal to hypotenuse cosine of the angle. CY is equal to hypotenuse. My hypotenuse is 120 Newton. That uppercase N is a unit that represents a force that is known as Newton. So 120 Newton, sine of the angle that is 60 degrees. How much is CY?
103.92.
120 sine 60.
103.92.
Yes, it's true. Sorry. 103.92. Sorry. Remember to write the units. These are going to be Newton. And this component of this force is going to be positive because it's going upward. And about the horizontal component, we're going to have the CX, or the horizontal component, is equal to the hypotenuse, that is 120 Newton, times cosine of 60 degrees. How much you got?
60.
60.
60 Newton. These newtons are going right or left?
Left and going to be
Left.
negative.
They're going left, and they're going to be negative. So you can see that this topic is very nice, but it's important that you know, that you remember that the side that is in front is opposite, and anytime we have opposite is going to be sine. The side that is touching the angle is the side that is going to be adjacent, and anytime you have adjacent side, you're going to be using cosine.
And how I gonna know the direction is left or right?
You have to see like the arrow, where the arrow is pointing at, okay? So I always, this time I didn't, but let me show you something. I usually show a superhero. Okay, I always show a superhero. And great. There it is. This is the one that I always use. I'm going to show it to you. So take a look to this arrow. This arrow is pointing in this direction. Okay? So what I do is I use the same. Okay? Wait. So what I do is I just put this Superman in the same direction as the arrow is going. Okay? The arrow and his arm indicates the direction at which this vector is going. So in which direction is Superman going? Is it going down?
Up.
It's going up.
Up.
Is